This video is for other useful reactions for aromatic compounds. It is the last video for chapter 17 before examples. The first one we will focus on is the conversion of nitro group to amine. So converting an NO2 group into an NH2. So in a more visually appealing way, we will take nitrobenzene and we are going to convert it into aniline. Now, as we just saw in the previous video, aniline is extremely useful as we can do nucleophilic aromatic substitution with it if we convert the NH2 into N2 gas. So how do we convert nitro into an amine? Well, first step, we could use hydrogen gas with platinum. Alternatively, we could use iron and hydrochloric acid, or we could use tin chloride with HCl. All three of those methods will convert a nitro group into an amine, specifically on an aromatic ring. Next, there's the removal of carbonyl. This is when you have acylated an aromatic ring and you wish to remove the carbonyl so that you have the alkylation product. Okay, so how do we do this? Well, once again, we can use our magic chemicals of hydrogen with platinum. We could potentially use zinc amalgam, which is with mercury, with hydrochloric acid, or the most popular one, we use hydrazine, which is NH2NH2 with some KOH along with some heat. Now that is the best option, the bottom one, hydrazine with KOH and heat, because there is no overlap with any other reaction that we need to be concerned with. So for example, as you can see, the hydrogen and platinum was already being used for the conversion of the nitro group into the amine. So therefore, if you were to have a acyl group on the aromatic ring 2, that would get converted into the alkyl group as you were converting the nitro group into the amine. So you're going to have a competing reaction, which is not ideal. Just for anyone that is interested in what the name of the reaction is, this is a Wolf-Kishner reaction. Finally, we will look at the oxidation to carboxylic acids. This is a pretty neat reaction. We can convert practically any alkyl group, as long as it's primary or secondary, into a carboxylic acid. So what do we need for that? We need a good oxidizing agent, so potassium permanganate will do, along with sodium hydroxide and heat. And we obviously need to protonate it because we're using basic conditions. We need to reprotonate our acid product. So this works for any primary or secondary carbon attached to an aromatic ring. So for example, if we take toluene, we can subject it under these conditions: KMnO₄, NaOH, and heat followed by an acid wash will give us a carboxylic acid. So we can convert toluene into benzoic acid. However, if we happen to have something like benzyl alcohol, we can also convert it into the carboxylic acid with KMnO₄, NaOH, and heat followed by acid wash. Okay, So pretty much any primary or secondary carbon, this is a secondary carbon, primary carbon, we can convert into a carboxylic acid.